The general update pattern. This is arguably one of the most difficult concepts with D3. A lot of people get tripped up on it, but also arguably the most rewarding to learn because it unlocks your ability to create dynamic, interactive data visualizations. We'll cover the general update pattern, how to manage a single element with the general update pattern, a nested version of the general update pattern, using classes with the general update pattern, animated transitions, and finally key functions for object constancy during animated transitions. Hey, we've got a new project. Let's meet our new client, Phil.
Hey, I'm Phil. You ever go grocery shopping and then you're shocked at the total cost when you go to the checkout? Well, listen to this. I got this idea for an app where it will track all the things you put in your cart, and so you'll never be shocked again when you get to the checkout. Let me give you an example of Julie. Julie's going grocery shopping, and here's what she does.
So Julie's going grocery shopping, right? And the first thing she sees is milk, $3. She puts it in her cart, and then she tracks it in the app. She types it into the app, and that's when it enters into the list of her things in the app. Now she's got it listed in the app. The app tells her, milk, $3. Julie continues grocery shopping and she puts eggs in her cart, but she enters them into the app as $20. This is a mistake. So she corrects the problem. She says eggs, $2, and then it updates in her list. And she's walking along and then she sees some cupcakes and she says, oh boy, I gotta have those cupcakes. So she puts the cupcakes into her cart, and as they enter into the list, the app tells her cupcakes, $5. She says, oh my goodness, cupcakes are $5? That's as much as the milk and the eggs combined. So she changes her mind about the cupcakes. She removes the cupcakes from her cart, and then she also deletes the entry in the app. And as she deletes the entry in the app, the cupcakes go away. They exit the list. Now when Julie gets to the checkout, she's not shocked and she knows exactly what's in her cart and what the total is going to be. That sounds like a great idea for an app. How can I help here?
We'd like you to create a visual representation of the items in the cart. This will be the main focal point of the app. And we need the list to update correctly as the items enter, update, and exit the list.
Got it. All right, that sounds good. I'll see what I can do. All right, so we got a new project, and this is what it's about. I think the first step would be to just present the listing of items on the screen as text. The first version of what we create can look just like this, just text, where each entry in the cart has one entry as text on the screen that says the name of the item and also the cost of the item. Let's get started writing the code for this. As usual, I'll begin by creating a new directory, creating a template HTML from JSBin, changing the title, and including the D3 script tag. What I'd like to do first is create a new text element on the page that displays one item from our list. The first thing I'll do here is to create an empty script tag and also create an SVG element that has width 500 and height 960. To put a text element on the screen, I will select the SVG, append a new text element within it, and set its text content to be hello text. Next, I'll create a local server with live server and access the page being served by live server. There's nothing showing up here. Why is that? If we inspect the DOM here, we can see that there is in fact a text element inside of our SVG element, but it's not showing up for some reason. To make our text element show up, I'm going to give it X and Y attributes. There we go. Now our text shows up. Our text is a little bit small there. I think I'll make it bigger by setting the font size. To make it closer to our mock-up from earlier, I'm going to set the font family to sans serif as well. The first item in Julie's cart is milk, and it costs $3. So I'm going to change the text to say, milk, $3. Next, I'll make a few minor tweaks to the exposition and the font size, just so that we're all set up to continue the work. I'd say we're off to a good start with the basic text representation. We can make this data-driven using a data join. This text value of milk, $3, should come from an array of objects, the data. Let's define a data array that contains one object that has properties name and price, and the name will be milk and the price will be 3 in dollars. Next, we can assign SVG to a separate variable and then create a data join by saying svg.selectAllText.data and pass in our data array that contains one object. Then on the enter selection, we can append the text just like we had before. This milk $3 is still hard-coded though. Next, let's make that text come from the data object. We can change the text assigned to be the result from a new function called textValue, an accessor function. This function will take as input D, one of our data objects, and will return this JavaScript string template that puts in the name plus $sign and the price. When this runs, it shows us the same thing as before, but now it's data-driven. Let's make a function called render that we can invoke over and over again with different data over time. We'd like our render function to be idempotent, and that means the following. Idempotence is the property of certain operations in mathematics and computer science that can be applied multiple times without changing the result beyond the initial application. In the context of the general update pattern, this means that the DOM elements that you have after invoking this render function will be purely a function of the input to the render function, and it won't depend on the state of the DOM previously. What we can do here is wrap our select all text blah 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 into a function called render. This function will take as input our data and also our SVG element, which we're going to call selection. I'll rearrange the code here so the render function comes first. Then, outside the render function, we select the SVG element, define the data, and then invoke the render function with our SVG element and our data. Next, let's simulate adding the eggs with the mistyped price after 1 second. To do this, we can push a new object onto the data array for the eggs with a price of $20. Then we can invoke the render function again, passing the updated data. But we'd like to do this after some time, so we can use set timeout, and then I'll pass 2000 here, which means 2000 milliseconds, which is 2 seconds. When this runs, you can see that 2 seconds after the page loads, eggs $20 is displayed on top of the milk, which is not what we want. To separate these out vertically, we can introduce a new variable called vertical spacing. Then we can use vertical spacing when we set the Y attribute of the text. We can add vertical spacing times I, the index of the element, and to access I, we need to wrap it in a function that takes as input the data element and the index I. Now it is separated by that vertical spacing, but I'll just tweak it a couple times to get it to be a nice looking spacing. Alright, this looks pretty good. We're adding the eggs at $20. Next, let's simulate updating the price of the eggs to be $2. First, what I'll do is render the eggs at $20 after 1 second. Then I'm going to refactor the code a little bit so that it's easy to see what changes between invocations. I'm going to pass the data array directly as the second argument to the render function. Now to update the price of the eggs from $20 to $2, I can copy-paste that set timeout block and just change the value of the price of eggs to $2 in the second array entry there. And then I'll change the timeout value to 2000, which is 2 seconds. So now after 2 seconds, the eggs should change price from $20 to $2. When our render function runs, we have data elements and existing DOM elements on the page. Our code uses the enter selection. The enter selection comes into play when there are new data elements and no corresponding DOM elements on the page yet. When we invoke the render function with the updated price of the eggs, there are existing DOM elements already for all of our data elements, so the enter selection does not come into play. So how can we make the price of the eggs update? To handle this case, we need to use the update selection. The update selection is also called a data join. When we apply a change to the update selection, it affects the existing DOM elements that have corresponding data elements. In our case, there's an existing DOM element for the eggs, and there's a corresponding data element with the new price. If we set the text on the update selection, then the updated price of the eggs will be shown. Let's take a look at our render function. This piece of code here creates the data join. The select all part finds the existing DOM elements. The value returned from .data is our update selection, also called the data join. Our code currently appends a new text element on enter. Our code also sets the text content on enter. We would like our code to also set the text content on update. Currently this is not being done, and this is why the price of the eggs is not updating. In order to set the text content on the update selection, we can just set the .text inside of the data join before we invoke .enter. This here sets the text on newly appended elements. And this here sets the text on existing DOM elements. Now the text updates correctly. Alright, that's how you can use the enter and update phases of the general update pattern. Now let's try to simulate that case where the cupcakes exit the cart. As our next step, let's add cupcakes to the list after 3 seconds. I'm going to compress this code a little bit and then add a new set timeout entry that adds the cupcakes at a price of $5 to the end of the list after 3 seconds. And when we run this, we can see that indeed cupcakes appear in the list. Let's have the cupcakes exit the list after 4 seconds. When we run this, unfortunately the cupcakes entry does not leave the page. The cupcakes are still there as $5. Why is that? How can we make the cupcakes text disappear? We've encountered the case on the right side of this Venn diagram here of having an existing DOM element that no longer has a corresponding data element, namely the element for the cupcakes. We can handle this case by using the exit selection. I'm going to make a variable called text that we'll assign to the data join. Then we can access .exit from the data join, which will give us the exit selection. And then we can call .exit.remove to remove all of the elements inside of the exit selection. Now when this runs, you can see that, in fact, the cupcakes text disappears. The convention with D3 is to have statements that create a new selection indented by 2 spaces, and have statements that modify an existing selection indented by 4 spaces. This makes it easier to read the overall flow of D3 code. Taken together, the enter, update, and exit phases comprise the general update pattern. This is the standard way of creating dynamic documents using D3, which, by the way, stands for Data-Driven Documents. Now our render function is idempotent.
This is fantastic! I like the concept, it's very clear. However, one of our engineers mentioned that there's some duplicated logic in the code. Is there any way we can address that problem?
Yeah, I'll take a look at that. To apply the logic of setting the text content to both the enter and update selections, we can use selection.merge to merge those 2 selections together and then apply that logic to the merged selection, eliminating duplicated logic. Alright, that's how we can use the general update pattern, also eliminating duplicated logic using selection.merge. Let's send this off to Phil and see what his engineers think of this.
This is a great start, but it needs to be more visual. The user needs to be able to really perceive the differences in the prices between the items. It needs to be easy to see the list and immediately say, aha, this is how much the things cost relative to one another.
We can achieve this goal of making it more visual by having bars that correspond to each item in the list. Since this will be on mobile devices, let's utilize the full width available by putting the bars behind the text items. This is what that would look like. The area of the bars here corresponds to the price of each item. We can add bars behind the text elements by using the same general update pattern for rectangles instead of text. We can define x as 0, y as the y scale of the y value of the row, the width of the bar as x scale of the x value of the row, and height as y scale.bandwidth. And y scale is going to be a band scale. We can move x into the enter selection because it doesn't depend on data. It's always going to be 0. The x scale will be a linear scale whose range goes from 0 to width. Width we can define as svg.attr width, parsing it into a number with unary plus. But we don't have access to svg, that's defined down below. So I'll just move that definition to up here so we can access it to get the width. Y scale will be a band scale, and the range will go from 0 to the vertical spacing that we're already using, multiplied by the number of rows in the table. The x scale domain will go from 0 to the maximum x value, and the y scale domain will be all of the y values mapped from each row. The x value will be the price of each item, and the y value will be the name of each item. If we run this, we see that in fact some big bars do show up. Let's make the rectangles steel blue. That's a nice color. Now when we run this, we can see that pretty much it's correct, but the text is not quite at the right place. Now that we have a y scale, let's use this to determine the y position for the text, which will be the y scale of the y value plus the bandwidth divided by 2, because we'd like to center the text within the bars. When we run this, we can see that the baseline of the text is in the center of the bar, but we'd like the center of the text to be at the center of the bar. To solve this problem, I always refer to D3 axes. If we inspect the DOM on this line chart from earlier for these tick marks, we can see that each of these text elements has a dy attribute of 0.32 em. This is what actually makes it centered with respect to the tick mark line. I'm going to set this dy value for our text elements. Also, I'll move the definition of the y attribute to the merged enter and update selections because this depends on the data, which may change. Now if we run this, we can see that the text is perfectly centered within the bars, which is exactly what we want. All right, that's how you can have bars with text in front of them. Let's see what Phil thinks of this.
It's a nice concept, but can we add a margin around the bars?
We can define a margin object with margins left, right, top, and bottom. From there we can compute the inner width as width minus margin left and margin right. Then we can use the inner width in place of width when defining the X scale range. Next, we can append a new SVG group element to our selection and give it a transform attribute of translate by margin.left and margin.top. Then we can use G in place of selection and append our rectangles and text elements to that group element instead of the selection, which is the SVG element. When we run this, see what happens. The bars look like they're going all the way across the screen. What's going on here? If we inspect the DOM, we can see that inside of our SVG element, there's many group elements. The rectangles and text elements get rendered inside each one of these group elements separately each time the render function is invoked. Why is this happening? How can we solve this problem of these duplicated group elements? This is happening because we're appending a new group element each time the render function is invoked. We can solve this by using the general update pattern. But what would be our data for our data join here? It needs to contain one element, and that's really all that matters. The most common pattern I've seen for this is to use an array containing null as the data for the data join. For example, if you look at the source code for D3.js, you can see this pattern used for the domain path. Studying the source code of D3.js is how I learned the ins and outs of the general update pattern. To solve our problem with multiple group elements, we can create a data join with an array containing a single element, which is null. I'm going to change const to let so that we can reassign G to be the merged enter and update selections. In the enter selection, that's when we append a new group element. We set the transform on the merged update and enter selection in case the margin may have changed. Because we reassign G here to be the merged update and enter selections, we can use that variable G in downstream code, and we can be sure that it's always our one single group element, no matter if it's the first time the render function is invoked or a subsequent time. Now if we run this, we get the correct behavior. Lastly, I'm going to tweak the left and right margins and also tweak the X attribute of the text so that it begins to the left of each bar. All right, that's how you could use the general update pattern to manage one thing, namely our group element that we use with the margins. Let's see what Phil thinks of this.
Oh yeah, that feels better, but it only partially addresses the aesthetic issues. Can we add some padding between the bars? And also, can we make the text a little bit separate from the edge of the bars?
Sure, yeah, I see what you're saying there. Let's adjust the padding of the band scale to add space between the bars. We can do this by setting padding, but notice that if we use padding, there's some sort of jiggling around of the bar height. It sort of changes. To fix that, we need to set padding inner to be twice the value of padding outer. Then I'll tweak the vertical spacing so that it looks about right. I'll tweak the padding just a little bit more. There we go. Let's see what Phil thinks of this.
This is much better, but one of our engineers mentioned that there's some duplicated logic around setting the Y coordinates. You think we can address that problem?
Oh yeah, I'll take a look. Right, see, this is where the logic is duplicated, once for the rectangles and again for the text. We can apply the general update pattern to a set of group elements by saying g.selectAllG.data, groups.exit.remove, groups.enter.append G. And I'm going to assign the enter selection to a new variable called groupsEnter. This will be useful later. On the merged enter and update selection for the groups, we can set a transform attribute that translates by 0 and that y coordinate that we're using from the rectangles. So I'm going to take that logic from the rectangles, replace the rectangle's y position with 0, and make that a function of the data element on the groups. We can remove that same logic from the text elements as well. We'd like to have the rects and the text elements as children of our groups elements so that they can sort of inherit the transform from those group elements. That's why we can set a value of 0 for the y coordinate of the rects and a value of bandwidth divided by 2 for the text elements, because these are the y coordinates relative to the translated group elements that they're going to be children of. The pattern we were using earlier doesn't really apply anymore, so I'm going to delete that code in preparation for a nested version of the general update pattern. We can say groups enter.append rect. This will append a rect element whenever a new group element gets appended. Then we can say .merge groups.select rect. This will merge the rect enter selection with what's effectively the rect update selection, this groups.select rect, which selects the rectangles that were already there inside the group elements. Then we can move our attribute settings inside the enter and merged enter and update selections, depending on whether they depend on the data or not. This is the so-called nested version of the general update pattern. We can apply the same pattern to the text elements. When we run this, you can see that the behavior is essentially correct, the same as it was before. But now, if we inspect the DOM, we can see that there's one group element for each entry in our data array. These group elements are translated by different values in the y direction. Inside of each of these group elements, there's a pair of rect and text elements. It occurs to me now that since x and y are both 0, we could just leave them out because 0 is the default. I'm just going to delete the code there that sets the x and y values on the rect elements. And it seems to behave just the same. I'm going to do a recap of the nested version of the general update pattern, because this is one of the most, tricky things to really understand, I find. Here we have the standard general update pattern applied to group elements. The only sort of odd variation is that we're assigning the enter selection to its own variable for later use. Here, we're just assigning a transform attribute on the merged enter and update selections for the group elements. This is also standard general update pattern, except that we're using a variable rather than defining the enter.append inside of the merge statement. This is the place where we really implement the nested variation of the general update pattern. Here, we're sort of piggybacking on the enter selection of the groups, so that whenever a group enters, we're going to also append a rect and set its fill to be steel blue. This is where we define the enter selection for our rectangles. This is the part that I found most confusing to really learn and understand, groups.select rect. Remember that groups is the update selection for the groups. It's a data join. That means it only applies to the existing DOM elements that were already there on the page. Now, if there's a group in this selection already on the page, that means that it was already processed by our groupsEnter.append rect, so there must be a rect inside of it already. That's why we can say .select rect here. This will give us the update selection for the rectangles. It will contain a selection of many rectangles across the various groups. This is where, finally, we merge the enter and update selections for the rectangles, and we apply some attributes there that may vary depending on the data. All right, that was a recap of the nested variant of the general update pattern. This pattern is also present in D3 axis. If we inspect the DOM on this line chart that we made earlier, we can see that there are group elements for each tick mark. Inside of each of these group elements, there are pairs of line and text elements. Let's take a look at the source code of D3 axis. Here we see the top level of the nested general update pattern present for the tick groups. And here's the nested general update pattern for the tick text. All right, that's how you can use the nested version of the general update pattern. Let's see what Phil and his engineers think about this.
The engineers approve, but the text seems a little weak to me. You think there's anything we can do to make it pop a little bit more?
I'll see what I can do. Mike Bostock has a nice solution for this in his example, radial normalized stacked bar. The idea is to add a white stroke to the outside of the text. SVG does not support this directly, but we can achieve it by having two text elements on top of one another, where the text element on the back has a white stroke, but the text element in the front does not. This gives the illusion of a single text element that has stroke applied just on the outside of the text. Let's apply the same technique for these labels on our bars. We'll need to have two text elements in each group. I'm going to make two copies of this code that adds the text. I'll name the first one text background and the second one text foreground. The background text is the one that needs to have the stroke set up on it. For the background text, I'm going to implement the same attributes we find in the radial normalized stacked bar chart example. Namely, fill is none, stroke is white, stroke length is 5 pixels, and stroke line join is round. Let's see what happens when we run this. We see pretty much the desired effect, but there seems to be something strange going on. If we inspect the DOM here, we can see that the text on the bottom shows eggs $2, but the text on the top shows eggs $20. Why is that? Why isn't it working? The problem is that when we select the text for the update selection, it's only ever actually selecting the first text element that appears inside the group. Namely, this one here is being selected both times, so that's why only this one is getting updated correctly. We can differentiate between the two here using classes. Let's try giving the background text a class of, say, background. And let's also give the foreground text a class of, say, foreground. This should solve our problem. We can apply a class of background to the text elements that get appended, and then when we select them, we can select all the elements that have the background class. We can apply the same pattern to the foreground text as well. Now when we run this, we can see that milk, eggs $2, there we go. That's the correct behavior that we want. All right, that's how we can use classes with the general update pattern. This is useful anytime you need to disambiguate between elements that have the same tag name, but they are used for different things. Let's see what Phil has to say about this.
This is great! The text really pops. I'd like to share with you some data we've collected from our beta users. I'd like you to simulate this data flowing through the system and show me what it would look like as it changes over time.
All right, sounds good. So he sent me this JSON file that contains an array of arrays, and each of the inner arrays is a listing at a given point in time. So I think what we need to do is load this JSON data with D3 and then just iterate through it, maybe at 1 second intervals, and see how the display in the app evolves over time. First, I'll copy the file data.json from Phil's email into our directory. Then we can load in the file using D3.json and print it out using console.log. When we run this, we can see in the console that an array of arrays was printed out. These arrays contain what should be displayed in the list after each step. Since we want to update our visualization each second with new data, the indices of the array correspond to the number of seconds that should pass before each of these updates occurs. I'm going to comment out our old code because the code we're about to write will replace its functionality. For each element of the data array, we can invoke a function using forEach. This function will take the list and the index I. For each of these lists, we should use setTimeout and then invoke the render function to render the items in this list. And the wait time in milliseconds passed to setTimeout should be the index I multiplied by 1,000 milliseconds. Now when we run this, we can see that it steps through the list of lists that's defined in the JSON file. So now Julie's getting apples, bread, bananas, onions, all kinds of stuff, garlic, smoked salmon. Oh man, 1475? Broke the bank. Finally, I'll delete that dead code. All right, we basically got it working. Let's see what Phil thinks.
Very nice! Say, could we sort the bars so that the most expensive item is at the top?
Sure, I'll give that a try. We can add a line here at the beginning of our render function that will sort the data in descending order according to the X values, the prices. All right, that's how we can sort the bars. Let's see what Phil thinks of this.
This is great, but it's a little bit hard to track what changes over time. They just sort of jump around, you know what I'm saying? So, could we add some animation so it's easier to track the changes over time?
Yeah, that's a great idea. Luckily, animated transitions is one of D3's strong suits. We can add animation to the positions by setting the transform on a transition. Now when we run this, the things should animate around. Look at that. They are sort of animating, but it's not quite right. See, the new items sort of fall down from the top. And this is because the transform is not initialized on enter. So it's sort of assumed to start at 0 and then go to whatever it gets transitioned to. I'm going to assign the transform value when the groups get appended, so they're initialized to where they should be vertically in the list. Now when this runs, the things sort of appear where they're supposed to be. But notice how they don't actually animate around. Why is that? By default, D3 selections assume that the identity of each item is associated with its index in the array, which is not really true in our case. things could get reordered. To fix this, we need to specify what's called a key function. The key function is the second argument to .data when you create a data join. This function takes as input one entry from the data array and returns a unique key or a unique identity for that item. We're going to use the y value, which is the name, and rather than writing an inline function, we can just pass y value itself, because that is a function that takes as input one item from the data array and returns the name of each item, which we'd like to use as the key of each item. Now when this runs, you can see that there's object constancy, meaning the milk and the eggs and the bread all sort of animate correctly over time. The visual objects that represent these data elements are consistent. That's how you can use a key function to achieve object constancy with animated transitions. We can also set the duration of our transition in milliseconds to slow it down a little bit. Now you can see the animations are a little bit slower. Let's consider the case of when an item is added to the cart. Wouldn't it be cool if that bar were to sort of grow into existence? We can achieve that effect by setting the width inside of a transition and then also initializing the width to 0 in the enter selection for the rectangles. Now when we run this, you can see that the bars in fact grow from nothing when they appear. Pretty cool. What about when something leaves? Wouldn't it be cool if we could sort of shrink the bar and then it disappears? In order to get at the exit selection for our rectangles, we first need to get at the exit selection for our groups. The groups need to exist for the duration of the transition, so I'm going to remove these group elements only after a transition which has duration of 800 milliseconds. Otherwise, the groups would disappear before the rectangles have a chance to animate. We can obtain the exit selection for the rectangles by selecting the rect element within the group's exit selection. Then we can transition the width to 0 inside the transition within the exit selection for the rectangles. Now when we run this, you can see that the cupcakes shrink down before they disappear. And also the cookies, they shrink down before they disappear. All right, that's how we can add some animated transitions. Let's see what Phil thinks of this.
These are beautiful animations. However, one of our engineers pointed out that there's some duplicated logic around setting the transition duration. Is there any way we can address that issue?
Right, I'll take a look. There is actually a way that we can define the transition once and then use it in multiple places. Here's our duplicated logic setting the transition duration. Before we render anything, let's define a transition and set its duration. Now we can pass that transition into selection.transition in these various places. Now there's less duplication and everything still works as expected.
All right, that's how you can define a transition once and use it in multiple places.
Let's see what Phil thinks of this.
This is awesome! We are fully satisfied with the behavior of this visual. However, our engineers have one final request of you, and that is, could you please package up this code into a library that we can easily drop into our code and have it just work?
Sure, my pleasure. Last but not least, let's take stock of our whole program and think about what makes sense to put in a library. This piece here that loads the data and calls the render function seems like it should not be in the library. This would be like the main program that invokes the library. Also, selecting the particular SVG seems like it should be done outside the library. Defining the accessors and the vertical spacing also seems like it should go outside of a library. The library should take as input the accessors and the vertical spacing. Also, these arbitrary things like the margin, the padding, and the transition duration should probably be specified outside the library. The code that extracts the width from the SVG, computes the inner width, sets up the scales, and implements the render function should probably go inside the library. Let's begin by creating a new file called visuallist.js. This will contain our library, which will expose a single global variable called visualList. Let's define a single variable, visualList, to be the return value from an immediately invoked function expression, or IIFE. This pattern gives us a closure that we can put variables into without polluting the global namespace. The next step is to include this script file into our index.html page. Let's start to sketch out the API of our visualList library. This can be a function that gets invoked with the first argument as a D3 selection with an SVG element, and the second argument can be an options object that definitely has the data in it as the first thing, and maybe we'll add more things to that options object. In our visualList library, I'll modify the arguments to take as input SVG and options, or actually I'll call it props, paying homage to React, because this is just like the patterns in React. Oh, I put that in the wrong spot. That should be actually a function returned by the immediately invoked function expression. We can extract the data prop into a local variable. The next thing I'll do is a wholesale copy-paste of the render function into our visualList function. I'll change selection to SVG because that's how we refer to the same thing here. The first thing we need but don't have is the X value accessor, so let's stick that into the props. We can pass X value into the props object like this. The next thing we need but don't have is the X scale. So I'm going to move that into our closure here. And we don't have inner width in our closure, so I'll set the range of the X scale inside of our returned function. The next thing we need is inner width. I'll move the definition of inner width into our returned function, and that depends on width. So I'll also move width into our function, which depends on SVG, which luckily we have. We also don't have margin, so we can stick that in the props too, and we can pass it in like this. The next thing we need is the Y scale. So I'll move the definition of the Y scale into our closure. And we'd like the padding to be configurable, so I'm going to set the padding inner and padding outer inside of our returned function. I'll set padding inner to a new variable called bar padding, and padding outer should be bar padding divided by 2. We can pass in bar padding to the props like this and unpack it from the props object inside our function. We also need the Y value accessor. Just like the X value accessor, we can pass in this through props as well. The next thing we need is vertical spacing, which we can also pass in through props. The transition duration is hard-coded to 800, so let's make that configurable and call it transition duration and pass that in through props as well. Looking through the code here, it seems the only other thing we need is the text value accessor function. Just like X value and Y value, we can also pass text value in through props as well. As sort of icing on the cake here, we can simplify this even more by bringing the SVG selection inside of setTimeout and using the .call API of D3 selections. Let's run this code to make sure it works. Oh no, we're getting an error. Unexpected token dot. Looks like this semicolon here. All right, so if we run it now, it looks like everything's behaving as expected. However, there is one issue here that the SVG is a fixed height. So if there's more items in the list than there is space in the SVG, then it just goes off the bottom, see? To solve this, let's have the library set the height of the SVG. So what should our SVG height be anyway? We were setting the range to be vertical spacing times data.length, but that should really be the inner height inside of the margin, the top and bottom margin. The height of the SVG should actually be this inner height plus the top and bottom margins. And we don't actually need a variable for that. We can just set it directly on the height attribute of our SVG. Now, if this runs, let's see, will it extend all the way down the page? Oh, you see that? When something disappears, things get cut off. That's not good. But it is extending down the page, which is what we want. But notice when the cupcakes disappear, watch this. Boom, the eggs got cut off. We can solve this problem by setting the height of the SVG inside of our transition as well. I'm going to temporarily add a hello div to the bottom of the page so you can see what happens here. I'll make it a little bigger too so you can see it properly. Now when this runs, you can see that the height of the SVG element transitions and animates, And also, that causes the div below it to animate as well. So whatever content follows our SVG will also be animated to accommodate the changing shape of the SVG element. All right, I'd say our library is working pretty well. All right, that's how you can package up a visualization as a library. Let's deliver this to Phil and his engineers and see what they think.
Our engineers are quite satisfied with your work. Thank you so much. It's been a pleasure working with you.
Likewise, it's been great. Hope your app does well.